Good morning, everybody. We're going to start wrapping up chapter 21. So chapter 21 is the alternative energy resources for more of the long-term alternative energy. And Nova Energy Lab is what we're going to be working on today. And basically what we're going to do is we're going to follow through a little bit of the energy lab, and then you're going to do a city design for renewable energy systems. So if you click on the following link, it's going to take you to the PBS page, Nova page. It looks just like this. And you're going to go through a couple videos and quizzes as you start this lab off. It's like a pre-lab portion. So you're going to highlight the answers that you think go with each of these lovely portions of that pre-energy lab. It does say to begin with the Finding Alternative Energies tab. So if you click here, you're going to start with the Finding Alternatives Most Plentiful Resource, and it goes on to the next question, so on and so forth. So you're going to head through those sections. The Storing and Moving Energy tab is the next one, which is right here. And then you are going to start to design a renewable future. So for this lab, you're going to be presented with the energy profiles for 5 different cities across the United States. Based on the data from the U.S. Energy Information Administration, city officials and local utility companies, they've given a snapshot of the city's current energy needs and resources. So you're going to be given a budget and renewable energy product target, and your challenge is going to design a system that's going to meet that target in the cheapest way possible. So it's kind of a twofold design. So your design, depending on the location, obviously, there are certain resources that are better for that location. Renewable energy system designs may include solar, wind, geothermal, or biomass. So to help inform your design, obviously, you need to pay attention to maps of that area. There might be maps that show you sunlight, maybe maps that show you wind capabilities and all of that. And obviously, that's going to impact what choices you're going to make for that particular location. You're going to then test your system. And when you design your system, you can test it against yearly historical data, which is actually all true data. It'll give you real-time feedback as well. And then you can power up. When the test is over, you'll power up your renewable energy system and find out if you actually met the production goals. So that will do it with all real-time data as well. And obviously to do that, you can click on the Play Game tab for the design challenge. When you're doing this, though, make sure, just like in other labs, you have to keep tabs of what you're putting in ahead of time, and then also recording your stuff at the end. So please have this lab up page by page with your other website here. So if we take a look at this, we'll play the game. I'm going to begin. So there are locations here. I could start in Tucson, Los Angeles, Vegas, Boulder, and Tennessee. If you take a look, there's a level 4 challenge, 2, 1, 3, and 4. I would start with a level 1 maybe first and work your way up. So here's Tucson, Arizona. Here's the average monthly demand that they need. The peak demand is usually in August. Makes sense. It's the hottest there, so they're going to be running their air conditioner quite a bit. Then we have our budget, and your target is to get 27,000 megawatts per hour. So we're going to take a look at that. If you look here, nuclear, natural gas, hydroelectric, they show you some pie charts for this. So I'm going to start to design my system, and I can choose in here what's going on. So I can do it by efficiency or by area, and this is solar. The average solar cost is 211 megawatts. Again, here's my available budget. So I can start to take a look. If you notice, the only option I have for Tucson is solar. Some of the other cities, you're going to be given several options for geothermal designs. This is the easiest one, so they only gave us one to work with. So I'm going to decide, do I want to have more area or do I want to have more efficiency with my solar panels? So you can decide, I'm just going to whatever, pretend. But I can also look at local potential. So here's where I am in Tucson. If I look in Tucson, here's the potential for the solar intensity in that region. So I know that I can capitalize quite a bit on this energy source. So you can make adjustments, take a look at the data that's been given to you, and you can test your system. So again, I was too low. I can redesign and retest and continue on with my project. But when I'm ready to go, oops, I'm over my budget. When I'm ready to go and have the rest of the testing done, I can then, there we go. So here's the design tips. You can continue testing or you can redesign. So you can go back and forth, taking a look at all the different things that you want to adjust. Make sure as you're going through this though, you have your targets, energy per month, your peak demand month, which we already know in Arizona was going to be August. The biomass potential, we don't have that for Arizona. We don't have geothermal, we don't have wind, but we do have solar. And it has a high potential for the use of solar. So I would highlight the high as opposed to the medium and low. And again, you can get all that information as you start to design your program and you take a look at the information in the local potential bar down here. So we know obviously it's in the orange, which would be on the higher end. Take a look at that. Make sure you record the area that you chose, the efficiency that you chose for that particular source. In this case, it's solar. The available budget that you have, the area that you used. And then when you're done, you can do the power up. You can complete the 3 questions that go along with it, and then you move on to the next locations. If you have any questions, make sure you put them up in Google Classroom and I'll try to help you.